Gentlemen, to week number 45, open Q&A. My name is Brian McLogan, and I am here to answer your questions. Thank you so much, guys, for joining in. I can see you. Tachina, Daniela, Disti, Gabriella, Chile. Thank you again, guys, for joining up. What I'm going to cover for you this stream is some extra multiple choice questions, which it seems like, I guess there's maybe just a delay, but I have some multiple choice questions that I want to cover with you guys on this live stream that have been pre-submitted. If you're interested to submitting any questions for any of my future upcoming live streams, then in the description down below, you can see there is a link for my Google form that you can go ahead and submit your questions. Every week, I go ahead and take a look at your questions, and I try to select as many questions that I can possibly cover each and every week. I'm not able to get to all of them, ladies and gentlemen. I do apologize for that. But that is one of those things I always just strive to be able to help you guys with your math. So thank you so much for submitting them. You know, I do have some very details that I want to show you guys, is trying to be as specific as possible for myself to be able to help you out. But yes, Grunch Amalan, Philip, Ryan, Young Cooley, Adam, Nash, David. Good to see you guys joining on. I don't know. I guess I'm just having a little bit of a delay. There we go. It looks like it's just a little delayed on my live stream. But there's a couple things, you know, I wanted to let you guys know. I know we're kind of getting into the semester exam season. Things are starting to change around. COVID cases are kind of going up, at least in the United States. People are going back to digital learning. A lot is going on. So one of the things that I have created, if you guys remember my live stream from last week, we talked about how to prepare for your semester exams. And I did create a free worksheet. If you'd like to go ahead and join on from that, when you select on the join for the free worksheet, then you do get added into my weekly mailing list, which I just send out a nice little email reminding you of the live streams every week, as well as, you know, just kind of giving you over some of the tips. I did do some extra tips in that weekly email. So if that's something that you're a little bit interested in and just kind of joining in and getting a reminder of my live streams, then feel free to go ahead and go into the description, and you can see I have a link here for the, where is, there you go. I have a link for the all math students, and that is just an exam checklist. One thing, if you are a pre-calculus student and you're looking for a little bit more advanced help, I do have a kind of private kind of mini course that I am offering for pre-calculus students. That is something that I'm offering, that I have offered inside of my pre-calculus course. So I am making that available during this exam season. It is a little bit more premium because I am giving up some of more of my private time to do a little bit more Q&A. But in there, I at least offer all of my exams and my reviews, as well as the answers, and me working through those reviews to help you prepare for the exam. So that is a little bit bonus, a little bit more than the checklist. But if that is something that you're interested in, feel free to go and take a look at it and then join in. I am doing a private live stream, I believe on December 6th, where it's only going to be for students that have opted into that mini course, where I'll just kind of take your questions and stuff like that. But all right, otherwise, I see you, Randy. Thank you for so much in, and Scrunch, and Amalan, Hamza, Jen, OCG. I am doing very well. Yes, staying healthy. Jake the Snake, Randy Cruz, Link. Hey, well, hiya, Jana. You teach them. Well, I'm happy to help you out, Jana. And there's somebody else with a nice big heart. Who is that? Dark. Well, I'm happy to see you, Dark. So let's go ahead and get started. Now I feel like everything's a little bit back in here. Let me go and pop out the chat here. Okay. So let's go and talk about some of the strategies for taking a math exam. Now, this is primarily just for multiple choice math exams. Because, you know, one of the things that we're taking inside my class, I didn't know how things were going to go for my school. I was actually assuming we were not going to be in school this long. I was actually thinking we are going to be going back virtual learning like very soon. And so that's one of those reasons why I gave up my planning period, why I was kind of like okay to teach other courses, because I just thought we were going to go back virtual. Like I did not think we were going to be in person for this long. But so far, at least in Florida, in the United States, we have been doing, we are going back to in person, and we've been staying in person. So we'll see how that kind of goes now, getting into the winter kind of season for us. But so one of the things that I did for typically a lot of times on my test, I always have a free response portion and a multiple choice portion. And with assuming that we were going to go virtual, I just said, well, you know what? I will just create my test all to be multiple choice, because that's going to be the easiest way for me to grade them. in an online setting. So that's what I've been doing this year. And, who knows, we might still go to digital. But for my previous exams, even my previous exams, we've always had an online multiple choice component. And I always gave my students this exact same advice. And that's what I wanted to share with you guys. Okay. Because I think it's really, really important. This is advice that I have kind of taken on myself. It's something I've kind of created. And I might have heard along the way, might be some snippets from some other teachers that I can recall. But one of some things that, I've taken a lot of multiple choice tests. And it's not just about math. It can be really for really anything. But obviously, getting out of high school, primary focus was on, my math test. But this is also something I applied when I got my real estate exam. And, there was a lot of multiple choice questions for there. And, so these techniques, I still use them for a non-math test. And they have helped me out. So tip number 1 is take the test 3 times. All right. That's tip number 1. Take the test 3 times. And hopefully this kind of throws you for a loop. And what I mean by that is take the test, do it the first time you go through a test, do all the problems you know how to do first. And this thing really bugs me because I can't tell you how many times I've had this where I've seen students taking their test and I'm like, why are you still on question number 10? Like you have like another 20 more problems to go and we have, 10 more minutes left in your test. Like there is not a rule, right? Unless it's an online test, but most even online tests, you can skip a problem. So there's no rule that you have to do question number 1, then do question number 2, then do question number 3. Do the problems you know how to do first. And if you don't know how to do it, or if it's going to take too much time, or you have to actually spend a little bit of brain power thinking about it, just skip it and move on to the next one. Do the problems you are most confident with first. Get those out of the way. That is going to kind of like warm you up a little bit, warm those kind of brain, functions going on, and maybe give you a little confidence boost. Like, okay, I'm getting things I know that I'm getting done. And again, it might not give you too much confidence. Maybe let's say you only know like 2 questions out of 45 or something, but at least you're starting somewhere. At least you're like, all right, here's some things I remember, I feel comfortable with. Then the second time, go back through the test again, and now do the problems that you feel comfortable with, like you kind of know how to do, but they're going to take a little bit more work. Maybe a little bit more thinking. You need to maybe check out your works. Well, thank you, Team Green. That's very nice of you for a super chat. I have to now stop my thinking there. I really do appreciate you going through math. I am very happy to be able to get you through your math, Team Green. Thank you so much for the super chat. I appreciate it. So hopefully these tips will definitely continue to help you out as well. Can you see my comments? I can, Gabriella. And the money, yes. Whenever you do a super chat, it brings me a big yellow on my screen. So even though I'm talking to my camera, I can see the big yellow on my secondary screen. But I can see your screens. I'm just not able to. I'm just not able to get to all of the questions and comments, though, Gabriella. All right. So where was I going with this? All right. So yeah, go through the problems that you know how to do that maybe are going to take you, just a little bit more time, and maybe you have to think through some of those things. Think through some of the problems, but the ones that you're like, okay, I can do these. It's just gonna, or I think I know how to do these, but they're not like the slam dunks, right? Do the slam dunks first. And then the last time going through the test, do the problems that are the most difficult, the ones that are confusing. You're like, I'm not sure if I know how to do this. This seems like a very confusing problem with a lot of steps. Do those problems last, okay? And because in the end, guys, there's no reason to finish your quiz saying like, oh, I couldn't do questions 30 through 40, right? Because I didn't have enough time. Well, what if 30 through 40 were like the easy questions, right? The ones that you knew how to do. Like, why are you leaving those till the end? You should be like, well, I had no idea how to do 10, 11, and 12. Those should be the problems that if you're going to guess on a multiple choice test, those are the ones you're going to want to guess on, right? So skip the ones that are most difficult. Scrunch, let's not keep on typing in the same thing on the chat, because then I have to go and put you in a timeout and stop all of my instructions. So thank you, my love, Laura, for stopping the spam. All right, let's continue on. So yeah, make sure you go ahead and get through those, do the problems that or if you're going to guess, if you know you're going to get one wrong or leave it blank, make sure it's the ones that are the most difficult for you. Okay, so that's tip number 1. The second tip I would definitely recommend is looking at the answers. And I remember hearing this tip like when I was in school, like, oh, look at the answers. Then I don't think I ever followed that advice. But but now actually taking a lot of tests and giving a lot of tests to my students, I realize there's so much good cues and tips that students can identify or understand about the question as they are if they just would look at the answers first. So a lot of times when I'm creating my key for my test, because I got to think like, not only do I take tests all the time, but now I create my keys for all my tests, right? And so a lot of these tests, I'm working through the problems, working through the answers. And like, rather than doing each problem step by step by step, I look at the answers. Then like that kind of gives me a little tip and a little hint of like, oh, I just need to follow this process. I don't need to do the problem all the way through. I maybe just need to work it into 2 steps and then I can find the answer. Or if I see what the answer is, maybe that might tell me what process or that I need to follow or what it is I'm exactly looking for. Or maybe just to recall my memory on something I should remember about that problem or what I'm supposed to do. So I do really think it is helpful when you're reading a question to look at those answer choices. And if anything else, a lot of times, those answer choices are going to say, oh, they'll give you the obvious, like, oh, those are definitely not the right choices. Now it's just between those two. And it's like, what do I need to know to be able to decide between these 2 questions? So there's a lot of good clues that are going to come away from the answers, not in every problem, but in a lot of multiple choice problems. So I definitely recommend looking at those answers first. All right. And then last one, which kind of ties into that one, but I wanted to kind of break it off, is to, again, look into like making sure you're reading the questions. Because if you're going to look at the answer and you're like, oh, this is what I need to do. And like everybody go through it. It's like, and then they just go through the math. But make sure you're reading the question, because a lot of times we see a problem, especially in math. And that's why, I wanted to really hit home with this on math problems. Like, especially in math, we like do a problem and we just start doing the same problem over and over and over again. Or like we see an equation and we're like, oh, we see domain, and like you just do the exact same process. But make sure you read the question to actually figure out what it is that the answer is supposed to be. Because a lot of times we get so used to doing the same types of problems or using the same process or the same formulas that, on a multiple choice test where, speed and time is important and we're stressed out, we won't read the question all the way through. And we'll just answer the problem the way that we think we're supposed to answer, or the way that we've done it in the past. And that's a lot of times how we'll get tripped up. So make sure that you just take a break, just like one little exhale, look at it and say like, okay, oh, I think I know it. Oh, that's what I'm supposed to do. Look at the answers. Okay, yeah, but let me just go ahead and double check, make sure this question is asking me exactly what I think it's going to be asking me or what I need to know. Because a lot of times I can't tell you how many times I've made the mistake. I see the question, I look at the answers and I say, oh, this is what I need to do. And I immediately just like connect the dots. And then I realize I'm like, oh, I got that wrong. How did I get that wrong? That was an easy question. And then I go back, I'm like, oh, that's not what the question was asking. This is what the question is asking. So just be very careful. We know that multiple choice tests, are time, you have a lot of stress. And a lot of times you look at the question that you think you know how to do it. You see the answers and you're like, oh, I definitely know what I need to do. But just make sure you take a step back and realize and recognize what it is that you're answering the correct question. On top of that, also make sure that you're checking for minor mistakes. I mean, I am like the king of minor mistakes, right? And so one thing that I always had to do, sometimes I would even say going through the test 4 times. I didn't really want to say go through the test 4 times in step number 1, because that's like a little, excessive, I would say. But I really do think you should be looking at, a lot of times the difference between one answer and another answer is like a negative symbol, right? Or just switching things around. So just be very careful. Make sure when you select an answer that it's the absolute correct answer that you got. Make sure that you are using parentheses and negative symbols correctly. I can't even tell you how many times myself get problems wrong just for those little minor errors. So especially when you have a multiple choice problem or the answer choices are very similar to each other, it's just some things switched around. Just make sure you do a quick little double check to make sure that you applied your mental math or that your work correctly, and that way you got the right answer, right? Because a lot of the multiple choice answers are going to take into consideration some of those minor mistakes. And I think it's kind of it's a tough way to get a problem wrong if you know what you're doing, but you made a little mental, error. but, depending on the course, that could be, important mental errors or not. So, but either way, hopefully those little multiple choice problems or questions those multiple choice tips help you guys out. And again, if you're looking for a little bit more tips as far as how to study for your upcoming exams, I did last week cover that in my live stream that you can go ahead and check out on my channel, as well as I have a downloadable checklist that you guys can do in the description. And if you are taking pre-calculus and you like some of my resources that I'm giving away for my own students in pre-calculus, then you can go ahead and download or go ahead and check out my little mini course that I'm offering my pre-calculus students inside of my course, where you guys can get access to all of my reviews as well as my semester as well as final exam. So go ahead and take a look at that. All the information and links are in the description for you to see if it's the right fit for you. All right, now let's get on to the questions. I believe I got 15 guys. I had over 50 questions submitted for this live stream. So, I do apologize. I'm not gonna be able to get to all of them. I'm only gonna get to 15, but the good news is, if you are unsure if I got to your question and you're like, hey, I don't have time. I think I saw somebody was asking like, hey, did he get to my question, or can he get to my question? Like, the good news is I am now able to, thankfully for my YouTube members, I'm able to transcribe all of my problems in my live streams. So therefore, if you have a question or anything that you are interested or you're not wondering, if you have a question that you're wondering if I am going to solve for you, then you can always check back with my live stream within a couple of days, and all of the transcribed, but they will all be time stamped. So all the questions and my process is all time stamped. All right, so therefore you can quickly find maybe a problem that you are looking for or something very, very similar. All right, so it's just confusing more and more. All right, so I am exhausted. I was driving all day today, so I need to take a okay, let's all right. I need to take a little mental break. Here we go. Let's get into some valid questions. So, excuse me. We're out of town for this weekend, so I've been driving, getting ready. I got school tomorrow. I got papers I got to grade. Tests and quizzes. I got 2 tests I got to grade. I got to wake up early, get that done. Oh, man. Oof. All right. Yes, you are correct. All right. Creator 5, you should super chat. You said, yes, thank you so much. Yes, you are. All right. So let's go ahead and get started with these. So I'm doing pretty good. I wanted to get these submitted on there. So I'm doing a little bit better by getting these posted. All right. So just make sure, a couple questions, guys, as you do submit your questions, if you'd like me to answer your questions on the open Q&A, then please make sure that you are using the Google form in the description down below. I know some of you guys are on the live stream, and again, guys, I check the messages. I don't have time a lot of times to get through any questions that are on there. So I want to make sure that I just want to make sure that I am available for you guys. That's why these submitted questions. But sometimes I do take questions off of the live stream chat. So, feel free to always add them. But again, that's also why I created the Discord, if you guys want any examples or help in something that's a little bit more personal from there. All right. So in this one, it goes, is there a specific problem you'd like for me to explain? Oh, of course, obviously I'm reading my own question. Yes, I'd like clarification on the vertical line test, how to do it. Well, that is from @theonlyebill for EB2. I can't remember what exactly their username was, but yeah, the vertical line test is fairly simple. If you have a function and, goes something like this, all you're simply going to do is take a vertical line. Let's maybe get a bit different color here. Let's like blue. And what the vertical line test basically tells us is if you can take this line and move it. Oh, come on, stop. I thought I It's going to allow me to do it. Yeah. As long as you can move this line across the function and it never crosses the function more than once, then it is what we call a function, because every x value has a unique only one y value, right? You can see how it only crosses the graph once there, right? So therefore it's a function. And no matter how I slide this left or right, it's only going to cross the function once. However, if you take a look at a function, like a sideways parabola, okay, and then do the same thing with this. Let's see. Okay, now, if you can see, as you slide this, you can see that not only is it crossing it once, now it's crossing the function twice, right? You can see it's crossing it here and here. Well, now if your input, which is your x, right, has two y coordinates, right? The x value, whatever that is, has two outputs. Therefore, it is not a function. So the idea with the vertical line test is just to take a vertical line. A lot of times it can just be an imaginary vertical line, but as long as it doesn't cross the function more than once, then it is going to be a function. All right, Aaliyah says, is looking for a multiplicity. What does it look like? How do we determine if an equation is a multiplicity of 3? Okay, so multiplicity basically is telling us a couple things. That means it's a repeated 0, all right? And that means it is a repeated 0. Excuse me. It is a repeated 0 as well as the behavior of the 0, all right? So let's go and take a look at two different functions. Y equals x minus 1 cubed, and y equals x cubed minus 1. Okay? So the difference between these two functions is the zeros here. Okay? This has a 0 of 1, right? This is what makes the function equal to 0. But that gets repeated twice, because technically you guys could say this is x minus 1 times x minus 1 times x minus 1. Right? So if you use the zero product property, x equals 1 3 times. So what that's going to do is that's going to change the behavior of the graph. So that's why the graph looks like this. Whereas this has a real 0 of 1, right? But it's not repeated. So this actually is going to have a behavior that looks like this. Now, so you can see it crosses. They both only have one x-intercept, but the multiplicity of 3 is repeated. So that's why it kind of has this slight curve here. Whereas this one is not repeated. Now, the important thing you need to understand, remember the fundamental theorem of algebra says both of these functions have as the number of zeros is 3. Well, here, there's still only, but they both only have 1 0. So what's going on? Well, this has one real 0. That's being repeated 3 times. That's the multiplicity. Here has one real 0. That's not being repeated, but actually has two complex zeros. So if you think of the difference of two cubes, that's how you determine them. So that's all multiplicity basically does. I mean, I'm going to cover another multiplicity problem to hopefully maybe go a little bit more in depth there. But if it's odd, it's going to cross. If it's even, it's going to bounce. Okay? And the multiplicity is when you're looking into a factor, a linear factor. So if you're going to have x raised to the first power, and then m equals your multiplicity. Okay? So m equals the multiplicity. Okay? So it's important that it has to be written as a factor. You can see here how this is not written as a factor, okay? That's why the multiplicity is not 3. Now you could write this as a multiplicity if you were to factor this down by the difference of two cubes, but I don't really want to go down this whole rabbit hole and get you even more confused maybe than you could already possibly be with multiplicity, because a lot of students have trouble with multiplicity. The main thing is you only want to look to it in factored form. So your polynomial has to be in factored form. The power of the factor is your multiplicity. If it's odd, it crosses. If it evens, it bounces. And I will do another multiplicity problem to hopefully let you know. All right, question number 2 is talking about the factoring trinomials as well as, I think just factoring trinomials when a is not equal to 1, as well as factoring perfect square trinomials. So in this one, the main thing, we actually did this recently in my Algebra 2 class, is look at the first two terms. If the first two terms are squared numbers, you could possibly have a perfect square trinomial. So what we want to look for is if we have a squared plus b squared, okay, that just represents a square number and a square number. If my middle term is 2 times a times b, then it's a perfect square trinomial, okay? That is the definition of a perfect square trinomial. So we say, all right, So if a squared is 4x squared, that means a would be 2x, right? And let's actually write this on. Yeah, let's write. So if I had 2x squared plus b squared, which would be like a plus 1 squared, and this is 2 times what? 2x times 1, then that is a perfect square trinomial. And you can see that, yes, that does work. So how do you write a perfect square trinomial? Well, that's just going to be a binomial multiplied by itself, which that is going to equal a plus b quantity squared. So therefore, it will be 2x plus 1 quantity squared. Okay. Now, in this case, I can see I have another 4x squared. I'm like, oh, okay, another perfect square trinomial. But 2 is not a square number, right? You can't take the square root of 2 to get an integer, right? The square root of 2 is going to be square root of 2. So there's a couple of different ways you can look at this. One way is you can look at using the AC method, and the other way is looking at just the understanding that all binomials can be, all quadratic trinomials can be rewritten as a product of two binomials. So I could say 4x and x, or I could say a 2x and 2x, right? Because I know the product of my first two terms always gives me my first term of my trinomial. And then my last two numbers have to multiply to give me 2. So it's going to be positive 1 and positive 2, or positive 2 and positive 1, right? It could be either one of those. Now, another thing we're looking at is the middle term. So I want my middle term to be the addition of these two products to add to give me a 9x. So I could say, what do I want to multiply by x, and what do I want to multiply by 4 to get me to 9x using the factors of 2, which are 2 and 1. Now, sometimes this is difficult for students to do in their head, and I think I have another video coming up about this to help students out. But that's why sometimes we'll rely on the factoring, the AC method, right, which I'll help you guys out with as well. So we can only use 2 and 1. Now, again, I automatically see, well, if I multiply a 4 times 2, that gives me a 8. And then here it'd have to be a 1. Well, 8 plus 1 would give me 9. So therefore I can see that is my correct answer. No matter how I put the 2 and the 1, I would never get the product of my inner and my outer products to add to give me 9x. So that's how I can see that works. Now, let's say you're like, what the heck did you just do? How did you do that? Well, again, another way you could do this is do what we call the AC method. So 4 times 2 is 8, and they were 9. Say what two numbers multiply to give us 8, add to give us 9. So multiply to give us, add to give us 8. No, multiply to give us 8, add to give us 9. I had that right. And that'd be a positive 8 and a positive 1. And then what you can do is you can break apart your middle term then by 4x squared plus 8x plus x plus 2. And then what we can do is we can factor by grouping. So now you can factor out a 4x. That leaves you with a x plus 2. And then here you can factor out a 1, which is an x plus 2. Factor out the x plus 2s. And you're left with a 4x plus 1. So that is another technique you could go ahead and use. But again, that means that you understand factoring by grouping and so on and so forth, which some students find as difficult as well. All right, let's go and get a move on it. So the next one is expand the expressions as a sum, difference, or multiple logarithms. So if you can't read it here, we have log base b of x to the 4th times the cube root of y. Okay, so the first thing we're going to want to do is I recognize that is, I can maybe put some parentheses here, that I can separate these as log base b of x to the 4th. And then we can separate a logarithm, the product of a logarithm, using addition. So that's going to be plus log of the cube root of y. Then remember, the cube root, I can rewrite that as a rational power. So that can be rewritten as log base b of x to the 4th plus log, that's base b of y to the 1/3. And now the last step of expansion is if whatever powers, I can always rewrite them in front. So I can rewrite this as 4 times log base b of x plus 1/3 log base b of y. And there you go. The next one was a geometry problem. So it says, given the figure, the measures of the central angles are given. Find the measures of the following arcs. So I don't have time to go through all these questions, so I'll just kind of get you set up with the first one in this one. All right, so if you guys, So if you guys recall, all the angles in a circle, right, from here over there adds up to 360 degrees, right? So I can rewrite an equation. I could say 5x minus 7, plus 3x minus 1 plus 4x minus 7 plus 3x minus 7 plus 3x plus 4 equals 360 degrees. Now we can just add all these up. So 5, so there's a 3, 6, 9. That's going to be 14, so that's what, 18x. And let's see, we have a negative 7. That's going to be negative 8, negative 15, negative 22, and then that'd be a negative 18. Minus 18 is equal to a 360. So a couple different ways. You can add 18 to that, or factor out an 18, divide by 18, and then add a 1, right? Because you could do it a couple different ways. But let's just add an 18. So 18x equals 378. And 378 divided by 18 equals 21. Okay, so now if you want to figure out any of those angles, then you just plug in 21 in for x, and then you can figure out any one of those angles. And I'm not really sure as far as the arcs. I'd have to go back. The only thing I remember on the arcs is s equals r times theta. But that would be assuming things are in radians. So I'm not sure. I actually have to look at, because I had another question from there. So I'm not sure what you would need to do for on that, but hopefully at least that helps you out with the angles. I need to think a little bit further on the arcs from there. I don't remember. All right. Athea asks, can you discuss a little bit about intercept zeros and asymptotes of a rational function? Absolutely. So she didn't give me an example of a rational function, which would have been a little bit easier, but there are some tips for at least the intercepts and the zeros that I think are kind of like nice. The asymptotes is a lot. So, I mean, I'm going to just give you a quick little rundown of it. But let's say you have a polynomial. I'll just, okay. Let's say you have a polynomial n of x divided by d of x. Okay, so here's a rational function. All right, so if you want to find the intercepts, so the x-intercepts are when n of x is equal to 0. So all you got to do is set the numerator equal to 0 to find the x-intercepts. As easy as that. The y-intercepts is going to be the constant over the constant. Now, these are some little tricks. You should remember the x-intercept is always when y equals 0. But again, when you plug y equals 0, the first thing you have to do is multiply d of x on both sides. So d of x times 0 is just 0. So 0 equals n of x. To find the y-intercept, that's when x is equal to 0. Well, when you plug x equals 0 into the numerator and the denominator, the only thing left you're going to have is constant over constant. So therefore, constant over constant is going to give you your y-intercept. The zeros is going to be the same thing. I mean, you're just solving for when y or f of x is equal to 0. So you're just going to basically set the numerator equal to 0. That is just going to be when f of x equals 0, right? I mean, nothing changes with that definition. The only thing you need to be careful with the rational function is watch out for holes. So watch out for holes, right? So simplify, right? Because holes, remember, are divided out. Holes cannot be asymptotes. I'm sorry. Yes, holes cannot be asymptotes, nor can holes be intercepts or zeros, right? So just be very careful. A lot of times students will find an intercept or an asymptote and it'll be a hole. It actually gets divided out, okay? To find the vertical asymptote, you're just going to set your d of x equal to 0. So to set your denominator equal to 0. And then to find the horizontal asymptote, you need to use the horizontal asymptote test. The horizontal asymptote test is basically a comparison of your numerator or your degrees. I'm not going to cover it, so I'm just going to verbally say it. When the degree in your numerator is larger than degree in your denominator, there's no I'll just do this. Degree in numerator is larger than degree in denominator, there's no horizontal asymptote. When degree in numerator is equal to degree in the denominator, your horizontal asymptote is your leading coefficient of your numerator, which we'll say is a, over your leading coefficient in your denominator, which I'll call b. And when your degree in your numerator is less than the degree in your denominator, then y equals 0. So this might not make sense to many of you if you're just catching this verbally, but hopefully you can kind of see, or if you're just catching it on the screen, but hopefully you kind of see it verbally. The slant asymptote only occurs when there is no vertical, no horizontal asymptote, and that is going to be the quotient. So y equals d of x divided into, or n of x, d of x, or I'll just say that equals q of x. Right? And that means q of x is equal to n of x divided by d of x. So actually dividing your denominator into your numerator is going to give you q of x. And again, that's only going to occur when there is no horizontal asymptote. All right, question number 7 says, is there a specific problem? So, oh yeah, this is proving identities. Okay, so whenever I see a trigonometric identity, sine squared of x times the secant squared of x equals secant squared of x minus 1, I always think Pythagorean identities. And if I already have a secant on the left-hand side, and so I'm not going to want to change that, but I recognize I can change the sine squared into cosine, right? And that'd be good. So remember, sine squared of x plus cosine squared of x equals 1. So if I subtract a cosine to the other side, I can rewrite this as a 1 minus cosine squared of x times secant squared of x. Then if you apply a little distributive property here, you get secant squared of x. Secant squared of x times cosine squared of x is just going to be 1. And there you go. That has been verified. Okay, so here's another example of the talking about the multiplicity. So this student was asking about finding the zeros of the function and then stating the multiplicity. Okay, on the factoring part. Yeah, I mean, this is not an easy factoring problem. I probably wouldn't use the AC method, right? So, you know, like going back up here, this factoring technique is great. Like if you get stuck, but typically it's going to be helpful to kind of do these in your head. The AC method sometimes can be not that very helpful when you're doing some more difficult problems. So like for instance, in this example, you want to factor out any of your forms, right? And you can't talk about multiplicity unless you have your polynomial in factored form. So I'm going to factor out a negative x to the 4th. By factoring out a negative x to the 4th, I'm going to be left with a 5x squared plus 11x. And then that's going to be a minus a 36. Okay. So now I need to factor this down. And the nice thing is I don't want to do the AC method. I don't want to multiply 5 times 36. Like, ugh. So what I could do, though, is I know that all quadratic trinomials can be broken down into a product of 2 binomials. Right? Okay, so I say, all right, what 2 numbers multiply to give me 9? And again, I'm looking for 11. Then I want the middle term to be 11. Now, the important thing is the last number here is negative. So that means I'm looking for the difference of my inner and my outer factors to give me 11. So one of them is going to be positive and one of them is going to be negative. For instance, I don't want to multiply 5 times 36, right? That's never going to give me a difference of 11. Nor do I really want to multiply by 9, right? 45. Because if you did 9, right, and then this would be 4, like 5 times 9 is going to be 45, and 4, like that's not even close to being 11. However, you know, 3, if you did like 3 and 12, you could try to do that in your head, but recognize I already did a 4, and I think of 9. So let's just kind of do this. 5 times 4 is 20. 9 times 9 and x, or 9 times 1, right? It's 9. Well, 29 have a difference of 11. So ding, ding, ding. Now I just need to determine which one's positive, which one's negative. Since my middle term is positive, I want the larger of my 2 products to be positive. So I say which one of them creates a positive product, or larger, 5 times 4 or 9 times 1. Well, 5 times 4. So that's going to be positive. That's going to be negative. Okay. Now you can see that I have a polynomial that's written as in a product of its factors. So now I can identify the multiplicity. So here's going to be multiplicity 1. There's a multiplicity 1. And this is going to have a multiplicity of 4 because technically you could rewrite a negative x to the 4th as a negative x minus 0 to the 4th power. okay? So find the zeros and state the multiplicity. So now that you have it written as your factors, you just set each and every one equal to 0. So you get x equals 0. That has a multiplicity of 4. Here you're going to have x equals 9/5. That has a multiplicity equal to 1. And here you have x equals -4. And that has a multiplicity equal 1. So again, remember, I'm just applying the zero product property. I'm setting each and every factor equal to 0 and solving. And again, where am I getting the multiplicity? That is the power of the factors. All right, the next question looks like a complex fraction. So rationalizing or simplifying a complex fraction. So in this case, what I'm going to want to do is factor these down, simplify. So let's see, I can simplify this to x plus 1 times a x minus 4. Here I can factor out a 3, right? And that's going to give me a x squared minus 1. Oh, geez. Seriously? Okay, so that can be further factored down into a x minus 1 times an x plus 1. Okay. So now all we need to do is multiply everything times my LCD. So what is my LCD here? Well, my LCD is going to be the denominator, or is going to be the power that all of my denominators divide into, which in this case is going to be 3 times x minus 1 times x plus 1 times an x minus 4. Okay, so when I multiply that by here, the 3's divide out, the x minus, oops, I don't want to do it here. Let's see, the 3's will divide out, the x minus 1's divide out, and the x plus 1's divide out. Leave me just with a 1 times x minus 4. Then in my denominator here, I'll have my x plus 1's will divide out. Leave me with a 3 times x minus 1 times a x minus 4. And that's going to be minus. Over here, I would have my x plus 1's will divide out, and my x minus 4's will divide out. Leave me with a 3 times a x minus 1. Okay. All right, so now we can just go ahead and simplify this a little bit further. We could distribute this to what? X squared minus 5x plus 4. So therefore, it'd be 3x squared minus a 15x plus 12. Minus, I'm going to use parentheses here, 3x plus 3. Uh-oh, negative 3x plus 3. Oh, wait, did I distribute this? No, I didn't. Be careful. Let's not double do the negative. Okay, so I'm going to put this in, I'm going to distribute this, and then I'm going to distribute the negative again. Actually, you know what? Forget that. We can just do this all at one time. So that's a negative 3x, and then it's going to be a minus 3. No, it is a positive 3. Negative 3x, and that'd be plus 3. Okay, so I did that right. All right, and then let's combine our terms one more time. So that's x minus 4 divided by 3x squared. Let's see, that becomes a negative 18x, and that's plus 15. So there you go. So main thing is simplifying all of your denominators and then identifying what the LCD is and then multiplying everything times your LCD. The main thing I want you to come away from this is once I multiplied everything by my LCD, do you guys see how I only got one more fraction? That's the important thing from there. All right. For next one, question number 10. Not something that I've covered a lot from on here, but so this is like a domain problem, but it's kind of similar to what we've looked at in terms of our quadratics when we have a quadratic under the radical. And there's a couple things we need to understand. So when we have a rational, right? So if I had t over 1 plus t, we know that t, I know that my domain is restricted for 1 plus t cannot equal 0, right? So what are the values that make that 0? And then also whatever my radical is, right? That has to be like t over 1 plus t, that has to be greater than or equal to 0. Those are your two restrictions. So we don't just want to solve this in this case, because if you multiply 1 plus t on both sides, then you're just going to have t is greater than 0, which is going to be, oh, well, it's only for x values that are great or t values that are greater than 0. Well, that's not always going to be the case here, because if you look at what this graph is, this t divided by 1 plus t, and I just went over my understanding of asymptotes, right? If you kind of graph this, as t over t plus 1, we know that t cannot equal 0, right? And so let's say, from here, based on what I already taught, I know there's a vertical asymptote at t is equal to -1. And I know there's a horizontal asymptote at y equals 1, right? Because leading coefficient over leading coefficient, because they have the same degrees. So as I go ahead and graph that, I just go and use my standard reciprocal function from on there. And you can see that this is what this, just by kind of looking at the point, looking at the points and plotting them and plotting some points, I find my x-intercept is when t is equal to 0. So I can say, okay, so this is what the graph looks like, right? And you can check out some points, check -5 and just kind of get an idea of what this graph looks like. But it is going to be the reciprocal function based on these asymptotes. So here's what the graph looks like. And you say, all right, well, the graph is greater than 0 for x values, or t values, that are larger than 0, as well that are less than -1. And that's very, very important, right? So you can see this is greater than for all values that are less than -1 and when for t is greater than 0. So my domain in this case is not all values that are not equal to -1 or for x all values that are greater than 0, but my values is going to be from -infinity to -1 union and 0, and then from 0 to infinity. Okay, so there you go. So you want to make sure you have an understanding of the graph as far as what's going to be under the radical. Question number 7 is from Lena. I think she was asking me to solve for n, if I believe. I can't remember. She wrote in some extra things I didn't copy. So she didn't say what to solve for, but she wanted linear equations. So let's do n. So sometimes we might write like a little colon, we'll say n. So how do you solve for n? So n is inside the parentheses. So the first thing we're going to want to do is get the n outside the parentheses, or get rid of the parentheses. And we can do that by understanding why do we have parentheses. We have these parentheses in here to represent a -3 being multiplied by the x and the n. So I'm going to distribute that -3 to the x as well as to the n. Okay, now I just need to use my inverse operations to undo what's happening to the n. So right now my n is being multiplied by -3 and it's being subtracted by 3x. So I add a 3x to both sides and I get -3n equals 4x, right? Because you combine x plus 3x, and then I'll divide by -3. And n is equal to a -4/3 x. And there you go. All right, next question. So this is sometimes the questions I get, and I have tons of problems like this. There's tons of other examples of how to write points like this. And I know, guys, a lot of you get very frustrated, but please understand, I'm just not able to, I really don't like creating problems. I really like, if you have a specific question on something, to let me know. But this was, I can definitely see, you can see that people are stressed out, right? And I'm just not able to get to everybody's questions. So I do apologize for that, guys. But for this student, I will try to do my best. So a lot of times, this is a very popular type of question. That if you have an equation like y equals 2/3 x plus 7, and they say write an equation that's perpendicular given through the point 3, 1. So the important thing we need to understand is what is the relationship between perpendicular lines? Well, perpendicular lines have what we call opposite reciprocal slopes. So if you have an equation, mx plus b, right? M represents the slope of the line. Okay, so if it's perpendicular, that means they're going to intersect at a 90-degree angle. So their slopes, one's positive and then one is negative, right? So that's what we call the opposite. And then they are reciprocals of each other. That means the rise and run are going to be reciprocated. So my new slope here is going to be m equals a negative. I wanted that to be the same. Dang it. I flipped these around. My bad. Never mind. I just want to make the numbers a little bit easier. So my slope over here is going to be a -3/2. Okay. So what we can use now is, if we want to find our new equation, we can use what we call our point slope form. So y minus y1 equals m times x minus x1. Okay. Now you might say, well, what does x1 and y1 represent? Those represent any point on the graph, right? You can, like, any point, all graphs are made up of x and y coordinates, right? So x1 and y1 just represent one point on the graph. And we have a point on the graph, right? We have -4 and we have 2. So let's call those x1 and y1. Then what do the x and the y represent? Well, the other x and the y represent all the other numbers that make up that equation, right? Because remember, a line and a parabola, whatever, there are a set of infinite many points. So all we're going to do is we're going to plug in my -4, my 2, and my new slope to be able to find my equation. So I have y minus y1, which is 2, equals a -3/2 times a x minus a -4. Okay, and then we just need to simplify. So a lot of times we'll say like write this as slope intercept form. So that's gonna be x plus 4, and then good old illustrated property. Y equal, oh sorry, and then let's maybe add the 2. Okay, so we get y equals, let's see, that's gonna be -3/2 x. And that'd be a 2 divides into 4. That's going to be a 2 times. 2 times this is going to be -6 plus 2. And we get y equals a -3/2 x minus 4. Now, what about if we ask for parallel lines? Well, parallel lines, guys, have the exact same slope. So my slope here would be m equals 2/3. Right? So they're going to have the exact same slope because they are parallel lines. They never touch. Okay? So parallel lines, again, we're going to do the same thing though. x1 and y1. So y minus 1 equals a 2/3 times x minus 3. Again, due to distributive property, let's add the 1 over here. So we have a 2/3 x. Let's see, 3 divides in that -1 times. So that'd be, now I'm losing my brain. So that'd be a -1, so that'd be -2. Plus 1, so y equals a 2/3 x minus 1. So hopefully that was helped out. Just to make sure you know the difference between parallel and perpendicular. This student saying, what was the linear parent function? That was going to be this one. The linear parent function. What is the linear parent function? There we go. That's slope-intercept form. Here we go. Here's the linear parent function. F of x equals x. So that is just the slope-intercept form, which is fine. It's, this is representing m and b where represent transformations. So that's why it's not the parent function. The parent function has no transformations, right? It's just the pure function, which is what we'll call the identity function. So that's going to be identity function, which would be f of x equals x. All right, number 14 says if f and g are two functions where f of x equals x cubed and g of x equals x plus 2, then g of f is. So remember, g of f is when you plug f into g. So therefore, that is going to be the function. So g of f of x equals a x cubed plus 2. And I think the student was asking, like, how do they know like that is the answer, right? How do you know x cubed plus 2 is going to be the correct answer? Well, let's see what this graph looks like. So that's going to have a vertical shift up 2 units, and that's going to be the parent function I've already kind of talked about. So it's not linear. Even means it's symmetrical about the y-axis. It's not that. Odd means it's symmetrical about the x and the y-axis, right? And if you flip this across the y-axis and then flip it across the x-axis, it's not going to be odd. So you could use like elimination here, or you can understand what 1-to-1 is. 1-to-1 is a function that passes not only the vertical line test, which we talked about in this chapter or in this live stream, but also the horizontal line test. And since it passes the vertical and the horizontal line test, the vertical line test tells you it's a function. The horizontal line test tells you it's 1-to-1. So therefore, that is why we have our answer A there. Miriam, I am not able to take questions not able to take questions at this moment. I am almost done, but I'm getting to those points, guys, where I will be able to take your questions in for you guys in just a second, even though I don't have much more time because I do have school tomorrow. But this one I'm just going to add on because it's very similar. And I think, Daniela, you asked me multiple questions. I'm sorry, Daniela, I'm not going to be able to get to all of your questions, but I will at least kind of get you started on this first one. So it says in the circle P, measure of angle RPS. So let's see, RPS, okay, is going to be 3W. degrees. The measure of SPT, so S to P to T, that's going to be 4W plus 30. And the measure of TPQ, so TPQ, is going to equal 5W minus 20. RQ and TU are diameters. Now that's important because if they're diameters, that means they are going to be half of the circle, right? So that means they're going to go through origin. That means they are going to equal their angles, right, is going to be 180 degrees or a straight angle. So the idea here is like the, the angle U to P. Actually, what are we looking for? Let's do the first one, TPQ. So what is the angle for TPQ? Okay, well, I know that the angle from R to P to Q is equal to 180 degrees. Since RQ is the diameter, right? That cuts the angle in half. Okay, so that's very important because now I can just say, well, RPS, which is 3W, plus SPT, which is 4W plus 30, plus TPQ, which is 5W, minus 90. That all equals 180 degrees. So let's see here. We get 3 plus 4 plus 5. So that's going to be 12W. And then minus 60. Minus 60 equals 180 degrees. So if we add 60, 12W equals 240 degrees, and divide by 12, W is going to equal 20, which is your answer B. But perfectly timing, guys, that takes me almost to an hour. There we go. So at least got to some of those. And yes, don't spam, guys. That's not very nice. Nobody really likes that. But I do have a couple minutes. I will kind of go back through my answers. Oh, hey, Addie. Good to see you on. And Jaya. Bye, guys. I have to go to school. Bye-bye. Oh, Dan, you have to go to school. Wow. Daniela, it's okay, sir. Yeah, I do apologize, Daniela. And I'm having a little trouble. I got to look back into the arcs, but hopefully at least this gives you kind of set up. I just don't have time because I've already been doing the live things for... but I'm happy you joined in, Danielle. But if you want to resubmit them back, some of those, I'll try to answer some more of those questions. But, I still have 25 questions I wasn't even able to get to tonight. So, hopefully at least this kind of gets you set up from there, as how to find those angles. Oh, I'm sorry. I didn't even answer your question. TPQ. No. W equals 20. I got to figure out what TPQ is. TPQ is, I am so sorry, that is wrong. Read the question. Remember when I told you guys the multiple choice questions? Read the question. Oh, I see 20. I'm like, oh yeah, no, that's W. That's not the question. TPQ is 5 times W. Jeez, I'm not even following my own advice. Minus 90. Okay, so 5 times 20 is equal to 100 minus 90, which equals 10. The answer is not 20. The answer is 10. There you go. Aha. So hopefully that was helpful for you, Daniela. I caught my own mistake. I listened to my own advice. All right. VB, Jose. I have a geometry final this week because I took it over summer. I'm so nervous. You got this. You got this. Go ahead and take a look at my guide, my review to help you prepare and study for it. And then hopefully if you missed the beginning of my semester exam or this live stream, then you can go and check that out. I give you guys some tips on taking those multiple choice tests. Hopefully that's helpful. Esper, you are very welcome. BMath, math is like a cup of coffee in the morning. Yeah, sure. I guess I'll take it. Yes, thank you, Addie, for always submitting in and helping so many guys, so many people for that in the live stream. But yeah, guys, I have all my questions. You guys can submit your questions each and every week. I try to do my best. I did not get to about 25 of you, or at least 25 questions that got submitted. So, we'll hopefully maybe do this for next week. Probably next week will probably be pretty light because people will be, at least in the United States, doing Thanksgiving. So it probably won't be as crowded for the American students. But for those of you outside the United States, still submit your questions and I'll still go live. Well, hey, Gabe, thank you so much for that super chat. I really do appreciate that. And hopefully all of my videos or these live streams have been very helpful for you. So absolutely, thank you so much. Um, well, yeah, we'll see what happens when I return back. Their tests and quizzes, Brandon, tomorrow. We'll see how that goes. But yes, thank you. I appreciate that. That's very nice. Well, hi, Skylar equals yes. So plus, I'm an 11 STEM students. Awesome. Good for you. Keep it up. So if you do not like how you do not understand it. Oh, yes. Tips from me. Haha. It's Jordan. You're leaving. Nobody's leaving, guys. We're doing this live stream. Ooh, maybe we should do a 24-hour live stream. No, I don't want to do. Well, actually, you know what? I have been thinking about doing a 24-hour live stream. I don't know why. That just sounds like one of those things. Just like a math 24-hour live stream. That sounds horrible. But you know, one of the things we just kind of like I also like to go off topic. But one of the things when I was a wrestling coach, which I thought was really cool that I did one time, was I did a 24-hour wrestling practice. Now, it wasn't really technically a 24-hour wrestling practice, meaning the idea was I was so like we obviously slept, you know, but we slept in the gym, and we probably did like 3 or 4 I don't know more than that, probably like 5 or 6. Let's see, we probably did like three training sessions, and then we did a match. And then we woke up in the morning, we had like 2 more training sessions. So it was like a long wrestling practice, but it was pretty cool. It was a pretty cool wrestling practice. Maybe I'll have stuff to do. Maybe I'll have to think of doing something like that for math, just to do it, you know? Who knows? Well, hey, Naman, I'm Anya, STEM for my advanced, love from India. Well, thank you very much. Happy to have you. Your brain be fried. I know, that's what I'm thinking. That would nobody will see. That's the thing though. Nobody would want to attempt to do a math live stream for 24 hours. Like, I mean, even after an hour today, I'm like, my brain is already fried. But I don't think. I mean, yeah, I don't know. I'd have to. My only problem is, I mean, I can do a lot of math, but like once you start doing a lot of like people think that, you know, I don't know, because I've done so much math, like math comes so easy to me, or I remember a lot, you know, and I probably, you know, I am not a math savant by any means. I forget a lot of the stuff, even like calculus. I mean, I taught calculus for 2 years. I have my math degree, you know, I took many calculus classes, and a lot of stuff, I just forgot it, you know, unless you're practicing, unless you're doing a lot of it. You know, there's just a lot of techniques and a lot of things I just, you know, just don't come to me. I have to go back and review them. So that's why a lot of, you know, calculus stuff or above doesn't really get on my live streams, just because when I want to explain something, I want to make sure I'm explaining it correctly, right? I want to make sure that I'm giving you a good explanation, not just, oh, here's, I think, how I remember how to do the problem, and then make a mistake or do it incorrectly or get it confused with something else. Like, that's not really benefiting anybody. So, but yeah. So that, so yeah, but anyways, you know, it'd be interesting. People could submit their questions for 24 hours, and then, we could just keep on doing them. And I think that'd be kind of cool. I think the cool thing is, because there's so many students that are not based in the United States. So they're, you know, that'd be just kind of cool to finally like be going live, actually on their timetable, right? You know, not like early in the morning or really late at night. I could just kind of go for it. So I don't know. Maybe we'll do something like that. Well, hey, JWAD, should everybody go ahead and subscribe to your channel now, since you don't want? Wow, man. I guess nobody wants. But I guess I'll subscribe to this Chash channel. Well, thank you very much, JWAD. I always appreciate people taking the time out of their day to bring in some love and advice back into my channel. Interesting. You're on my live stream though. So what should I focus on before taking Calc 3? I don't really remember taking Calc 3. So, I mean, this is kind of stupid. I mean, I don't really remember. Obviously everything from Calc 1 and Calc 2, I'd probably say would just be as far as I remember, Calc 3 is really just that extension of Calc 1, Calc 2. There's really nothing I think that you need to be worried about. From there, I think as long as you feel comfortable with Calc 1 and Calc 2 material, then you'll be perfectly fine. You know, so just go ahead and focus on knowing, make sure you know that stuff, and I think it'll be okay. All right. All right, guys. Well, I think I have caught up my live stream for tonight. But just a reminder, if you guys want to submit your questions for next week, feel free to go to my Google form, which is in the description, and you guys can go ahead and submit your questions for next week. I'll be going live at 9 p.m. Eastern Standard Time. If you're looking for a checklist of how to prepare for your upcoming semester or final course exam, I do have that in the description as well as a little mini course for those of you that are in pre-calculus, but it is a premium kind of pre-calculus course because I do some extra live streams in for that. So otherwise, guys, thank you so much for joining in. Thank you so much for joining in on my live stream. I wish you guys a great week, and I will see you next week. Cheers.